Hey Shiraz, I'm just trying to remove this guy.
Oh, okay.
Just doesn't allow me to hold and move it. Okay. All right. How are you?
I'm good. How are you?
Good, good. Where are you
I'm
dialing?
in. Are you all guys from Dallas or just Texas?
No, I'm not neither Dallas, neither Texas. I'm in Wisconsin.
Oh, nice.
I don't know where we left. Yeah, I think
I tried to see like the part one. I was not here like last time, so
okay.
I did complete that, but
Okay,
part two.
good. So did you start on the assignment?
Not yet. My work schedule is like getting harder now.
Okay.
Having this migration from Azure to in Azure from AWS.
Okay.
So yeah, I
Yeah,
didn't get any this week.
usually I think I wanted to start. I thought I'll finish the learning by Saturday, and I couldn't finish. I just finished it like a few minutes back.
Uh, started the assignment sheet yet?
Sorry?
Did you started the assignment two yet?
No, not yet.
Okay.
Hey, Sunita.
Yeah, hi Rufi.
Hello. I think I think folks may join. I'll just send a text. Uh, I'll- okay. I think let's get started. So I think last time we left on fairness and classification. Uh, and we can just go through. I think these are theory slides, and then we'll jump into I think the neural networks, and then we'll jump into module 3. So fairness and classification. Classifier can, I think I may have already forgotten this like last 2 weeks back. Classifier can be used to make real world decisions. It impacts things in life, who gets an interview, who should we lend money to. I think first two cases he says it makes sense. The third one, it's like online suspicious activity, those are valid cases. But if someone is criminal based just on their face is not a right thing to do, because humans are trained on anti-discrimination laws, and it's hard to train a model around anti-discrimination. So I think whenever we design classifiers, we need to ensure they are fair in some way, in the same way. Human making this decisions are typically subject to laws, as I said. And how do we ensure classifiers are fair in the same way? So you have to just make sure they are fair. Many other factors to consider when deploying classifier in the real world: impact of false positives, the confusion matrix, but we'll focus on fairness here. So these are ethical risks. So just having accuracy on a model is not enough, was the key takeaway on this slide. Evaluation of this fairness. So classifier needs to be evaluated beyond just accuracy. So if we have different population groups, we need to make sure classifiers are fair for every group. So I think so he has two population groups. participants from pi 1 will score higher on the test than the people from pi 2. That's kind of a discrimination. Same ability, the ground truth, but one group gets higher score than the other for the same ability. So like this person, Annie Clearly, in 1996, 1968, ran a test. A test is a biased if prediction on a subgroup makes consistent non-zero prediction errors compared to the aggregate. I think it's usually for the same ground truth, which is like based on their ability. If two groups are getting different scores, that's what it's trying to convey. Individuals of X group could still score lower on average, but the error should not be consistently impacting X. Member of pi 1 has test results higher than member of pi 2 for the same ground truth. So it test penalizes pi 2 is the takeaway. So I think anything you guys want to add? Okay. Evaluating fairness. Classifier need to be evaluated beyond just accuracy, as we discussed. Fairness in classification ratio of predicted positives to ground truth positive must be approximately the same for each group. Group 1, 50% positive movie reviews. Group 2, 60% positive movie reviews. A classifier classifying 50 positive in both groups is unfair regardless of the accuracy, since it penalizes group 2 by underpredicting. So allows for different criteria across groups, and imposing different classification thresholds can actually give fairer results. Can't we just make a classifier not dependent on sensitive features like gender? And answer is no. So discrimination, the idea is it is easy to build classifier that discriminate even without meaning to. So a feature might correlate with minority group X and penalize that group. Bag of word features can identify particular dialects of English, like or code switching using two language impacts classification on social media, etc. I think these are just example. Zip code as a feature is correlated with race. I think he gave an example, like somebody staying in like specific zip code could be associated with some race, and like you could penalize that group. Reuters, I think Amazon scrapped the secret AI recruiting tool that showed bias against women. I think that's the reference to that. So women's X organizations, women's colleges where negative weight featured. Accuracy will not catch these problems, very complex to evaluate depending on what humans did in actual recruiting process. So accuracy doesn't catch these. So that's just an example. Takeaway: what minority groups in the population should I be mindful of? Review sentiment, movies with female directors, foreign films. So I think the point is like be aware of your data, understand the minority groups, and like test for the biases. There could be like even Google had released their first model, and like there were some discrimination, and it flopped. Can I check on one of these fairness criterias? So like testing is important. Do aspects of my system or features it uses introduce potential correlation with protected classes or minority groups? It's just like make sure that some minority groups are not affected, and just test for those negative use cases is the takeaway. So the last topic is neural nets. So we have a simple like 3 features. He has considered 4 examples here. So good, bad, and not good or not. So simple bag of words features. All data points are on the same plane, so linear classifier is able to separate these things. So all data points are on same plane, and so no linear classifier is able to separate. So I think you can see like both the points are here. Not suitable for NLP. So other methods such as bigrams adding more features but not suitable for NLP. kernel method also have undesirable properties from standpoint of NLP he talks about. And that's the reason why we need to transform the data into a latent feature space that allows to separate the features. So that's the idea behind neural nets. So what's happening here is you have the weight and the feature metrics replace fx with a non-linear functional. And so here, so this is the one. So you took the weight vector and you replaced it with z, and z is defined as a latent feature space. So you have the non-linearity function, which is of type d by n matrix. And then you have, sorry, so this is non-linearity function, and v is d by n matrix, and fx is in n-dimensional vector. So then what does it say? So we take this and we classify this, and v plus g give us useful latent features. So I think this is more of a theory. I think tan h and ReLU are those non-linear functions. So this is a hyperbolic tangent. And I think he had an example which he walked through. So anything, Himanshu? Yeah.
Yeah, I just wanted to add, Rafi, and thanks for this. There's an example which comes later on in
Yeah.
module 2, I think, where he explains again. And this whole combination of one of the nonlinearity function, it could be hyperbolic tan or ReLU or something else, which we had studied during deep learning also.
Yeah.
That
Yeah.
and how it changes. So if you're not able to find it here, you will find it in subsequent notes.
Yeah. I think there was a video where it talks
Yes.
about how
Yes,
does
it does.
like it's an animated video. Maybe we can watch
Yes.
that. So I think that's like usually allows you to segregate these functions, and I think we have to go down and look through an example. So this is an example of neural networks. Suppose we have v x1 and x2 are two features, and this is a simplified example, which is so what is happening here? Tan 0 is 0, tan 1 is approximately 1, tan 2 is equal to 1. And tan of x1, just trying to understand this. So we have x1 and x2. So x1 is 1, that's positive. And x2 is 0. So that's that. And 0, 1, which x1 is 0. And x2 is positive. So that's that. So these are two examples here. And 1, 1. x1 is 1. And x2 is 1. So did anyone get this?
What I remember from the video was that essentially trying to explain that how neural networks will be able to represent these vectors. And when we create Z, which again essentially runs as a chain function of the feature vector, and when it gets multiplied with the vector, which is n by d, which is v, and subsequently when we put nonlinearity to it, so essentially we are converting these vectors into log probability of I mean, in terms of log probability, and subsequently when we optimize it, I think it will be there in the next slide somewhere where it talks about how to optimize it using one of the either SGG or one of the gradients and how it moves. That was the whole
Yeah.
I think idea when he was
He
trying to
just
explain
gave
it.
a simplified example. I think he
Yes.
said two positives are, I think We don't have to like literally put it, but here they are not separable. So by transformation, we get this, like negatives come onto this plane and it's easily separable. So that was his, he's just saying we are transforming the space. So this space was not like classifiable or differentiable. This transform space makes it easy to classify just using like a simple tanh function was his example.
So did we like transform it into like 3 dimensions or like with the tag?
Yes, essentially the whole idea is to subsequently it comes. The idea is to translate or transform the words either in terms of bigrams, or later on it'll be another model which he will use, where they can be put into word vector and context vector, and
Okay.
that's how the neural networks come into play. So it would be in a latent space. So a typical word which would have letters would get translated into numbers, which is more comprehensible to a neural network. And that's how they realized in 1957, I think, somebody who was able to do it. They realized that yes, they could. But then again, because of AI winter, nothing much happened. And then recently, 2015, word to vector is one of the models which they started using to have NLP, which is run on deep learning. That comes somewhere in the next video where he talks about it.
Yeah,
But
I
the
think
idea is to
I'm gonna
yeah.
show that I think we have to click the link. I'm unable to click the link on the PDF for some reason.
Yeah. He had mentioned that the idea is to exponentiate and then subsequently normalize to create those log probabilities. So it's easy for us and a machine to understand that what is the context of that particular vector. But yes, it is in latent space. It is multi-dimensional.
Yeah,
Makes sense.
my machine is not behaving properly. Just give me a minute. Have this. My Chrome just quit on me.
How another quick question would be, how did you guys download this PDF?
How did we download what?
The PDF, like I don't see this one in the modules, or is that in the modules, like the one that he has?
Yeah, these are his notes. So
Oh, these are in the
yeah, I just put everything in the. Come on, I just
There's
put
a URL you can download all the PDFs from. They're all packaged, Shiraz.
Oh, okay.
They're all packaged in a zip file.
Yeah, just give me a minute. I think my
No
machine
worries.
is. I'm trying to click that link. I think that visualization is important, and Chrome is like just quit on me. Can someone paste the link from that thing so I can
Yeah,
just click on it? I think
I'll-
that would be helpful. It's the chat window. Yeah. I think that I have that. I think this article is very good. I think if time permits, we should read that.
Shiraz, if you look at the chat, you will see a link that I just pasted. That file has everything you're looking for.
Perfect. Yeah, apparently, like, I'll show you the screenshot, what I'm going through. I'm not seeing any links on my canvas now for like yesterday.
The thing is, I actually go through the videos on YouTube. It's
Oh.
always available. I know people sometimes go through Canvas. I'm not sure why, but YouTube has his whole playlist there.
Yeah, I had this playlist saved, but and when I'm on my PC, I try to like do canvas.
Okay.
Yeah. Something is wrong with my machine. If anybody wants to share that visualization, I'm only able to share the PDF expert for some reason. If someone wants to share, go ahead.
I have some notes. I don't have all the notes.
No, not the notes, the link that Himanshu pasted.
I can share it just to demonstrate how it's getting
Yeah.
transformed from 2 dimensions to multiple dimensions. I think you'll have to allow us to share.
Oh, yeah, you have to allow us to share, Rufi. You own the meeting settings, and the settings don't allow sharing.
I think let me share it. Multi-pin allow. 10 seconds current ask.
Also, since morning, I think there's some issue with the Canva. It's not uploading the videos, but as Razal mentioned, I think YouTube has the option of using it there.
Yeah.
Stop sharing. I think now try. I think I stopped sharing. Does it allow?
Let me try. It does allow. Can you all see my screen?
Not yet.
So this is a document which was prepared by this phenomenal person. I'm not sure how to pronounce his name, Olah. So he has very interesting notes, and it demonstrates how from a two-dimensional space, neural network will be able to translate this into something which can be a different representation. So had it been, his idea was that if it's a linear model, it will not be able to differentiate between these two, the blue and the red data set. And when it is put through a hidden layer of neural network, it becomes like this. And then there's a visualization which is created, which professor also shows in the video. This is the visualization. Sorry.
Yeah.
If you remember from the DL class, professor kept talking about squishing the model, the data set into fitting the model. So it happens, and then it demonstrates over here how it can distinct the two, the red and blue, separately without losing.
That's good. I think we can continue. I think.
Yeah, I'll stop sharing. You please go ahead and share.
Yeah. More. Okay. Can you see my screen? Okay. So again, I think as Himanshu showed, we have a linear classifier which will struggle because it's unable to distinguish these 2 points. So when you have the neural network, sorry. So the linear classifier is just warping the space and allowing you to classify these 2 curves. So I think this is again Z1 and Z2. It's just like given this we saw vectorization and softmax. So so you have this probability. So that's this part, the three classes have different weights. So you individually calculate these weights, and you line this is represented by these vectors. So basically you're calculating the dot product. Each dot product results into some final score. And the softmax is taking, it's exponentiating as well as normalizing. So it does two things: exponentiate and like sum over the whole population of that space, gets normalized and gets represented into a probability that corresponds to the class probability is what he's trying to communicate.
So the function above is basically softmax, right? When you exponentiate and divide by the sum of all the other probabilities,
yeah,
it does it for everyone, and that function is softmax.
Yes. So
Okay.
it represents this. So it represents this part and this part.
Yeah, gotcha.
So we write softmax WFX. So that's like a W is capital. It's just like a matrix of these vectors. So previously, I think he explained it very well. I have previously tried to understand softmax, but I think this is a great example. So logistic regression with neural networks. So we studied neural networks. So this is for single scalar probability. This can also be represented as P of Y over X. So it's weight vector per class. W is number of times classes. So I think we already discussed that. And then this is another representation. Feedforward neural networks with one layer. So this is similar to the previous slides. So I just took a copy of that. So this is another representation of what's happening. You're taking the n features, you're going through V, which is D by N matrix. You're applying the non-linearity. It could be tanh or ReLU. And D are the hidden units, D hidden units. So you get some score Z. So that's that. And then you apply D, W, num classes times D, and apply softmax to get to the class probabilities. So that's another example here. Any questions? Okay. Training neural networks. So you have that, I think that's from the previous example, and the Z is that we are maximizing the log likelihood of training data, use loss as negative log likelihood of the training examples, and minimize that. So this one is equivalent to this. And I think I didn't understand the slide deck, so I have like I got some ChatGPT notes at the bottom. So I is the index of gold label in this class problem. If the gold label is at position 2, then the cell.
So he explains it. Sorry to interrupt, Rafi, but he explains this in a video later on, and he essentially mentions that, for example, let's say the gold level is 0, 1, 0, and so the index of, or not index, but then 1 is at location 2, so position 2. So we will use E2 as the representation of the gold level is. The idea is either to maximize the likelihood of training data aligned to the gold level, which is the ground truth, or like you had mentioned somewhere in your notes, or minimize the loss, so that we are training the model in a way that it is getting aligned to the gold level. And he explains it, I think, in a module where he talks about how we can leverage PyTorch for doing these calculations in
Yeah.
I think it comes over. Yeah.
So this was like I think this was very helpful for me at least to understand. So softmax output, I think this is that. So I think that's we already know. So I was trying to understand how does this like this equation, we got this, but how did he arrive at this equation was not clear to me. So I just like studied a little using ChatGPT. And what it does is log likelihood of correct class. The goal is the training process is to maximizes the likelihood or equivalent of minimizing the negative log likelihood of a correct class for each input. As you said, Himanshu, the likelihood for the correct class I star is given by that equation, taking the log of this log likelihood. So we are taking a log, simplifying the log likelihood. Like since it's a division, I think by the rule of logs, it becomes this first term minus the second term is equivalent to, like, we are just applying log here. And the first term simplifies because log exponential of x is equal to x. So that just becomes x, and that is represented by this first equation. And the cross entropy loss is defined by the negative log likelihood of the true label. So the loss for the given input x, true label I, is this. Substitute the expression for log y is equal to x, we get this, and this simplifies it to this. This is another common form of cross entropy loss. So I think this is equivalent to, yeah, so he's saying like there are two representations of this. One is this and the second one is this. We provide as negative log likelihood without the extra negative sign, and it focuses more on maximize the log likelihood instead of minimizing the log likelihood. This is for minimizing the log likelihood. So the key component of the equation, the first term represents the scores, and this term is normalization factor that ensures the output is a valid probability distribution. This is the denominator of softmax function. I think you guys can read unless you guys wanna like. I think backpropagation in picture. So here he's saying that he's just explaining what propagation happens. I think his explanation was not that clear. I think we studied, and I think there are YouTube videos, like I think Blue Brown or so. He explains exactly, but I think he goes at a very high level and he tries to explain how we are calculating the backpropagation. But I think we know from deep learning. So I'll go to the next slide. And again, I think this was his example, but I think somehow I think he said we're calculating the gradient with respect to W looks like logistic regression can be computed and treating Z as features. Layer closest to the output. So this is the top layer. Yeah. If anybody wants to add anything, but I'm just gonna skip this.
I think you should skip this because it's really complicated in real life.
Yeah.
So I learned all this maybe a year ago and I've totally forgotten it. So
yeah.
And he did say you don't need this for our course.
Yeah. Himanshu, go ahead.
Yeah, I just wanted to add, yeah, absolutely what you guys mentioned. But most of it would be actually taken care by PyTorch because we'll be using it until we get stuck somewhere. So he says it in the end of the video that it's perfectly fine if we don't dwell deeper into it. But like you mentioned, there are videos on YouTube which very, very smartly explain this.
Yeah, there is like, I think blue, brown or so. I think there is, I went through it and it takes a while to read that. I think it took me 1 or 2 hours to understand it, but he goes through a whole example and he has a YouTube video as well as uh, a write-up where you can go step by step. Like on YouTube, like some people like you can watch it, you understand, but after 5 minutes you'll forget. But I think the writing, the words are helpful, and he has like nice uh, animated GIFs. I can find that and I can send the link if anybody is interested. Computing gradients with backpropagation. I think even I'll skip this. This again, he's trying to explain how the gradient is getting calculated. Combine backpropagation gradient forward pass. So I think here, like PyTorch, he's just explaining PyTorch, how PyTorch works internally. So I think this is kind of a quick refresher of PyTorch. I think since most of us have gone through deep learning, we know. And he is just trying to equate how this diagram is represented in the code. So just a representation. So input to neural network. Whatever you define with torch dot needs its input as some sort of tensor, whether it's an integer, word.
Take the deep learning, so this would be helpful for me, I guess.
Sorry?
I said I didn't take the deep learning class, so this is my first class.
Okay.
It would be like helpful for me.
Okay. I think deep learning videos are also available on YouTube. If you want to just watch them and like educate yourself. But I can go through it. I think we may have to rejoin. I think in 2 minutes it will cut.
I can, yeah, if everybody has like already did that, so I'll just go through it on my own. No worries.
So he says, I think here the point he is trying to make is like, don't do complex math within the back propagation because it may screw up. Don't do the math inside the module. So sometimes it may screw up the back propagation. Training and optimization. So this one hot vector, I didn't quite understood. I think this is just that 0, 1, 0, what Himanshu you told, but I think this is a term. I think this one hot vector, I think should read up. So that's my action item later. Then this is just a PyTorch refresher, training a module. You define the module, initialize the weight and optimizer for each epoch. You batch for each batch of data, zero out, compute the loss on the batch, AutoCAD, compute gradient, and take step on optimizer, run on a dev test. So this we know from deep learning. So this is a practical technique. Batching data gives speed up due to more efficient matrix operation. Reduces the time each epoch takes. Need to make computational graph process a batch at the same time. So instead of vectors, we have matrices. Input is like batch size by number of features. Goal label is batch size times num classes. Make an update. This is a matrix sum of loss for the whole batch. So batch size is 1 to 100 often works well. So important for speed as well as optimization. Again, this is just, I think, looks like basics of what we learned in deep learning. So basic formula, training basics, compute gradient on each batch, use first order optimization, example, Szegedy, Adagrad, etc. This is some practical tricks, the deep learning. To understand this further. I think, yeah, he is just going through this. So initialization does matter.